The objective in this lesson is to be able to find the slope of a line given the graph of a line or given the coordinates of 2 points on the line. Also to be able to use slope to determine if lines are parallel or perpendicular. Given a line, we will be able to determine several points that make up parallel and or perpendicular lines through another given point. Let's begin by recalling what is slope. Another way to describe slope is rate of change. Remember that slope is the rise over the run, also known as delta y over delta x. This is called delta. That's how we say it. And it means change. So slope is the change in y over the change in x. The slope formula is y sub 2 minus y sub 1 over x sub 2 minus x sub 1 because the change is found by subtracting the y values and the x values. Also recall that an increasing line has positive slope. We look at what is happening as we read the line from left to right. Looking at the right side of the line, a line increasing going up will have positive slope. A decreasing line will have negative slope. As we read from left to right, see how on the right the line is going down, the slope should be negative. A horizontal line, or a line that is constant, has a slope of 0. See, it is neither increasing nor decreasing. Also, a vertical line has an undefined slope. Often people use the memory trick hoi vux, where the H stands for horizontal because it is a horizontal line. The O stands for the 0 slope, and the Y is for that it crosses through the y-axis. It has a y-intercept, and the equation would be y equals. So we think of y-intercept and only a y-intercept and a y equals equation. Kind of like as if this were 5, the equation would be y equals 5. Similarly, vux for vertical line has an undefined slope, and it only has an x-intercept, or the equation could be x equals 5. See, there's only an x-intercept, and if this is passing through 5, the equation would be x equals 5. So you remember these things from Algebra 1, and we will be using those. Now, we also remember from Algebra 1 about the slopes of parallel and perpendicular lines. Parallel lines have the same slope. Notice in the graph here that they are going in the same direction. If we calculate the slope by finding integral points, like here and here, points that cross through a vertical and horizontal line, we can count the slope. The slope of line A, I'm going to count from the left to the right. So from the left, I'm counting 1, 2, 3, up, and then to the right, 1. So the slope of line A is 3 over 1, or simplifies to 3. The slope of line B, I'm going to first find some integral coordinates here and here, and then 1, 2, 3, and over 1. Again, the slope of line B is 3 over 1, or 3. So we see that these slopes are equal to each other. They are the same. Therefore, I know these lines are parallel. Perpendicular lines have slopes whose product is -1. The slopes are also known to be opposite reciprocals. That's another way we can think of them. Opposite reciprocals. Let's take a look at these slopes. I'm going to find integral points, integral coordinates, and I'm going to count the slope of line J. 1, 2, 3, up, and to the right, 1. So the slope of line J is 3 over 1, which is the same as 3. I'm going to find a couple of points on line K, such as here and here. And I'm going to count from left to right. This time it's down 1 and 1, 2, 3. So the slope of line K is -1 over 3. Notice these two lines do not have the same slope. If I multiply them, 3 times -1/3, I get -1. The product is -1. Or simply we can look at them as opposite reciprocals. Positive and negative are opposite signs, and reciprocals means they are flipped over. That's how we tell when we have perpendicular lines. Let's practice these examples. Determine if the following lines are parallel, perpendicular, or neither. I need to find the slopes for this. So that's what we will do. Find the slopes. Line 1. I'm going to indicate that I'm finding the slope of line 1, kind of like how I did here. M for slope, a subscript of the line that I'm finding. So slope of line 1 equals. Now I'm going to use my slope formula. Let's recall that it's y sub 2 minus y sub 1 over x sub 2 minus x sub 1. X and y is how we label the points. This is my first point, and this is my second point, just because it comes in those orders. It doesn't really matter which point we call 1 and which point we call 2, as long as it's both of these coordinates are at the same point. So we start by subtracting the y's. Start with the y's. -4 minus -1 over, and now subtract the x's. 6 minus -1. And then we can type it in our calculator or simplify. -4 plus 1 is what that is, over 6 plus 1. There we go, -3/7. Now let's find the slope of line 2. Here is our xy and xy. We start with the y's. 0 minus 7 over 4 minus 7 equals -7 over -3. -7 divided by -3 makes positive 7/3. A negative divided by negative is a positive. Notice that these are opposites, negative and positive, and 3 over 7 is the reciprocal of 7 over 3. Because these are opposite reciprocals, these lines are perpendicular. We can write the word perpendicular, or we can use the symbol for perpendicular. Recall the symbols for parallel and perpendicular. Parallel is like the L's in the word parallel. That's the symbol for parallel lines, and the symbol for perpendicular is the upside down T. Let's try example 2, or you could pause the video, try it, and come back and check on your work. Line 1. Slope of line 1. Let's label xy, xy. 1, 1, 2, 2. We always start with the change in y. -4 minus 2, and then the x's. 0 minus -3. -4 minus 2, -6. 0 plus 3 is 3. That simplifies to -2. Let's take a look at the next line. Slope of line 2. Start with the y's. 0 minus -8 and 2 minus -2. That makes 8 divided by 4. That makes +2. Now, these are opposites, a negative and a positive, but they are not reciprocals. Since they are neither opposite reciprocals or the same slope, these are neither parallel nor perpendicular.